Okay, so only a couple questions from here, then you can start review out of the book. I'll give you a little handout tomorrow, and then Thursday is the test. I think this is probably one of our longest units so far too. I think the other ones had like 7 lessons. This one's got 8. Okay, little example to help explain what's going on. This is quite practical. We got pizza. Okay, so here's David's pizza, and he's got some pepperoni, and he's got some lovely green peppers, and of course we got some mozzarella cheese. Lots of it, and lots of it, and lots of it. Okay, he eats half a pizza. All right, chomp, 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 chomp. All done. I was going to get the highlighter, but that's good. Okay, then he eats half of what he's got left. Right? Chomp, chomp, chomp. Then he eats half of what he's got left. Chomp, chomp, chomp. Then guess what? Just for a change, he eats half of what he's got left. Okay? And then he eats half of what he's got left. And then he eats half of what he's got left. How much longer could he keep going and doing this in theory? Yes. As long as he has a nice microscope and a really sharp pizza knife, he could do this forever. Okay? Practically you're saying, well, what? Okay? But he could never finish the pizza, in theory. Okay, there's always going to be half of something left. Eventually that something's going to be too small for him to even eat. It'll be too small for an ant to want to take home to its nest, okay? In practical. But in theory, he could keep doing this forever. In practice, why can't we do this? Because eventually the piece is too small, A, for him to cut, and B, for him to pick up, okay, with his big meaty claw hands. Okay? But in theory, we could do it forever and ever and ever. Represent this situation with a geometric series whose first term is, we're going to start at, remember like this T0, T1 thing? Okay. We're starting at T1. We're not including the one whole pizza. We're going to start at a half. Then what did he have? Yeah. And we're not going to actually use commas here. This is a series. Then what? He had an 1/8 left. Then he had 1/16, so on and so on and so on. Determine the values of A and R and find a formula for S of n. Okay, what's A? 1/2. What's R? Yeah, half. That's what we multiply each thing by. Or, for those of you who really love fractions and want to practice it, what's that divided by that? 1/2. Okay, sum of n. Okay, so this one, and like I said, guys, I'm looking this up. Okay, I don't even have these things memorized. I want to use this one. Okay. Have A, have R, okay, substitute that in, so that's 1/2 times 1/2 times n minus 1 all over 1/2 minus 1. Okay, all I did was the substitutions. What's a half take away a 1? Okay, I can't really simplify anything up here. Down here I have -1/2. How can I simplify this? Do I have a half on the top and a half on the bottom? Yeah. I have a -1/2 on the bottom, so if I divide that away, what's left down here? -1. But can I just put the negative up here? Is that the same thing? Yeah, so I don't want to have negative. That might be confusing. And I ran out of room. Okay, so I have negative 1/2 to the n minus 1. Can I clean this up a bit? You can only FOIL if you have two binomials, okay? Yeah, that's the reason distribution law. Yeah, okay, I can multiply this -1 by everything in the brackets. So that's negative, I better now bracket this, minus 1/2 to the n, minus times -1 is +1. And then let's just rearrange that. Let's go 1 minus 1/2 to the n. Okay? Why did we want to do that? Actually, and this isn't even correct. You know why? Because that n looks like it's just on the 1. I'm getting lazy. That's got to apply to everything there, right? That's 1/2 to the n. It's not just 1 to the n over 2. So technically we should do that. All right. Use this table feature of a graphing calculator to complete this table. Well, for the first two, we should be able to do this. Okay, if n is 1, that's 1/2 to the 1, which is 1/2. What's 1 minus 1/2? 1/2. This is 2, then that's 1/4. What's 1 minus 1/4? 3/4. Now the rest gets a little trickier, so let's do that. I'm going to put in 1 minus 0.5 to the power of, instead of an n, an x works. We don't care what variable it is. Okay? If I were to graph that, that's what it looks like, but it's saying the table feature. And let me show you this, because this is kind of cool. Second function, table. There we go. So if you have one of these, why do it by hand? Okay, because these get a little tricky, right? 1/2 to the 6th power. What's 1 take away that? Well, here it is. 0.75, 0.875, 0.9375, 0.969, let's just say. 0.984. Put in the equation. Second function, you see this table here in the yellow underneath the graph button? Boom. You won't have to do this on a test, okay? It's nice to know. We will revisit again, okay? If we really need to know how to do this, guys, I'll teach it, right? I'm not just going to show you in 10 seconds. Okay, how about I get the rest? What's after 6? How do I do that? Well, there they all are. 0.992, 0.996. Do we see kind of a pattern happening here? 998, 999. Guys, ask me after if you really want to know how to do that, but let's follow this, okay? All right. Plot these on the grid. Here's n from 1 to 10. What are the values? This is 0.5, so if n is 1, that's here. If n is 2, that's 0.75, halfway between 1/2 and 1. That's here. N is 3, 0.875, where's that? 5, 6, 7, 8, that's 0.9, so it's just before 0.9. Okay, 0.94, I don't know, how about there? 0.97, a little bit bigger. 0.98, a little bit bigger. 0.96, a little bit bigger. 0.998, 0.999 is 10, way over here. You didn't really need to graph this. What is this getting closer and closer to? What value? Yeah, 1. So what would we call 1 here on this graph? That's an asymptote, right? I don't know about you guys, but the first time I was ever introduced to an asymptote, the teacher told me it goes out and it never touches the line. And his line was touching. And I'm like, well, what are you talking about? How could it go on forever and ever and ever? Okay, it didn't make any sense to me, but might not make sense to you, but it happens. I don't care what value you put in here for n, put in a billion, it still won't be 1. It'll be really close to 1, but it won't be 1. Okay? This goes closer and closer and closer to this line, but never touches it. There's a word for this. This is a convergent series. It converges upon some value. In this case, it converges to 1. Okay, and number 1 I wanted to put here. It gets closer and closer to the value of 1. Okay, so you can conclude, in theory, there is no sum. Okay, but in practice, we can conclude it does converge towards this number. Okay, so the answer is 1. In this case, remember, this was a pizza. Explain why the sum should be 1. Because eventually you can argue the whole pizza gets eaten. It's all gone. There's nothing left. Okay? That's common sense, but in theory, like if you're doing masters in math and stuff like this, you can argue, nope, it never does get eaten if you do that. Each cut a half each time, you'll always have some piece left in theory. Okay? Too small to be Dannon full, but in theory, right? Okay? So that's a convergent series. Now, let's look at something, not in a real practical question, but for this infinite geometric series. By the way, everything you've done so far was not infinite. It stopped. It terminated. What's the antithesis of infinite? Finite. Yeah. And how do you calculate the sum if it keeps going on forever? You can't, unless it converges. Okay? So that's why today's lesson is called Infinite Geometric Series. This is infinite, ... It keeps going on and on and on. Okay? Now R is 2. What's A? It's also 2. Okay, let's see what happens with this one. Okay, S of n is A, R to the n minus 1 over R minus 1. Okay, substitute. A is 2, R is 2, and 2 minus 1. Can I simplify that? Yeah, that's 1, so I don't even need it there. So 2 times 2 to the n minus 1. Okay. Put that in your calculator. 2 bracket 2 to the power of x minus 1. Don't need the bracket, but let's put it there anyway. Okay? We want the table. Second function, graph button says table, and I don't want to write all these down. Let's just have a look. That goes up to 10. If I want to make this number bigger, okay, what happens? My question is, does it look like it converges upon some value? Definitely not. Okay? The bigger n is, the bigger the sum is. 1 to the exponent of 6, that's what that says. Okay? 6.7 to the exponent of 7, that means 7 zeros after the decimal, if you haven't taken chem right now. Okay? It's getting huger and huger and huger. Okay? Exponent of 9, that's billions. That's like how many people are on Earth 30 years ago. Okay? So So this thing, as n gets bigger, this thing gets bigger and bigger and bigger. That's all I want to say. I don't want to write down the numbers. As n approaches infinity, the sum also approaches infinity. Mathematically, that's like universal language. Okay? There's not much English there. So what was the difference between the first example, it converged to some value, and this example? Well, it must have something to do with r, right? What was r here? Okay, so if it's a half, it converges to some value. If it's 2, it doesn't. It just keeps getting bigger and bigger and bigger. It's infinite, which means we never, it's undefined is the word we like to use now, right? Okay, so if I was going to plot that, that's what it looks like. This is called not convergent, divergent. So you can't say, well, the book says the sum is an infinity. It does not have a sum as n goes to infinity. Okay? It's a bit of an argument. Like I say, we kind of change our minds on this. Is it undefined when you divide 0 into 1, or is it infinity? Okay? Well, I was taught it was infinity. Now we're saying, no, some professors got together in some big gala meeting and said, no, we want to call that undefined. Okay? Okay, so whatever. All right, so if r was a half, it converged. If r was 2, it diverged, and there was no sum to infinity. Let's just look at a couple values of r and see what happens. We're not going to fill out this whole table. Let's see what happens. And this is a good little introduction. We're going to get a whole chapter on inequalities. Okay, so it's good that we're looking at a couple now. What does this say? R is less than -1. Yeah, okay? And if we're sticky with this, it kind of makes like an L shape. Less. Okay, I have some kids telling me that their elementary teacher taught them the alligator thing, and the eats the bigger thing. And did I tell you a story about the elementary teacher who said if it points towards the window, it's always greater? And then the kids went to a different classroom with the windows on the other side of the room, and they got all the questions wrong. Okay, well, you know. Anyway, r is less than -1. Okay, so I just want to do the first one. I want to do r to the n and see what happens. This is -2 to the power of 1, which is -2, so on and so on. What happens if n is really, really, really big? What is -2 to the power of 100? Yeah. Okay, graph. I'm going to wait a sec. Clear. That's -2 times. First of all, is the answer positive or negative? It's positive. Negative at times, an even number of times, this is always positive. 2 to the power of 100. Is my calculator even going to like this? Whoop, that's too big. 1.3 to the exponent of 30. That's pretty close to the mass of the sun in kilograms. It's pretty big. It's huge. What do we think? Does that converge towards some number? Times 10 to the 30, the exponent of 30, right? That's like moving that decimal 30 spots to the right. It's a lot of zeros. That's approximately. Okay, yeah. Squiggle equal, approximate. Okay, so if r is less than -1, this is what happens. Looks like it diverges. What happens if r is some value between -1 and 0? Okay, so again, inequalities we haven't done yet. That says r is less than 0, but r is greater than -1, right? And r is greater than -1. This says the same as this. So in other words, in between -1 and 0. For example, -1/4. Okay? If I go -1/4 to the power of 1, well, that's just -1/4. If I go -1/4 to the power of, whoop, not 30, 100, what happens? First of all, I don't need the negative there, do I? I know that's going to be positive. 1/4 is 0.25 to the power of 100. How'd that happen? What does that number say? 6.2 to the exponent of -61. So it's approximately 6 times 10 to the -61. So here, this was 30 zeros going this way. This is 61 zeros from there. Okay, so 0.000, another 55 of them. Okay, 6. What is that number close to? It's pretty close to 0, isn't it? Can we say it converges towards this value of 0? Okay, and the bigger n is, if n's 1,000, it'll even be closer to 0. Okay? So you can say that converges. If r is between these numbers, it converges to 0, right? That's pretty close to 0. Okay? What happens if r is between 0 and 1? For example, you can pick anything here, a half, 3/8. Okay, they just chose 2/3. Okay, 2/3 to the 1 power is just 2/3. What is 2/3 to the 100th power? 2 divided by 3 is 0.666, but I don't want to write all that out. To the power of 100. Two something to the exponent of -18. Is that a pretty small number? That's 18 zeros in front of the 2. It's not as small as this one, but what do you think would happen if we chose a bigger value of n? It would be even smaller still. Does that converge towards 0, do you think? Yeah. Okay? So, we're just investigating this, right? Let's see what happens. See if we can come up with why they're telling us what they're going to tell us. What if r is greater than 1? For example, 3. What is 3 to the 100? Do I even need to put it in? It's probably a pretty big number. Let's just prove it. That's 3 times 3 times 3 times 3 times 3. That would be cruel if we got like a grade 7 kid to do that. Okay? Exponent of 47. That's the mass of every planet in the solar system in kilograms. That's a pretty big number. Okay? All added together. Huge. Okay? Something times 10 to the 47 is huge. Does that converge towards some value? No, it just keeps getting bigger and bigger and bigger. There is no sum. We don't really want to call it infinity. Okay. I know that's hard on our brain, first block. The sequence is convergent as n gets bigger and bigger and bigger and approaches the value of 0 if r was -1/4 or 2/3. Okay, it got closer and closer to some value that was 0. And it diverged if r was -2 or 3. That's pretty much all the choices of r we could take. Okay? If it's even bigger than 1, like 3, if it's 20, well, the same thing's going to happen. Okay? If it's less than -1, I don't care what you take. -20, -40, -100, same thing's going to happen. Here's the part here that kind of strange things happen, right? That's where it got to 0. That's where it converged. So here's what you guys got to remember. it gets closer and closer to 0 provided r was between -1 and 1. Now, do you want to think of that as a fraction? Maybe, but be careful, because like 4 over 3 is a fraction. Any rational number can be written as a fraction. A proper fraction, okay, maybe that's not helpful, because I've gotten this question before. Just think of it like that. We should be able to figure out if 1/8 is in between -1 and 1, right? Is -4/5 in between -1 and 1? Yes, it is. Okay? And if it's not in between these two values, okay, if it's less than -1 or greater than 1, then it gets bigger and bigger and bigger, which means it diverges. So I'm not going to talk about this. I want to get right to the formula. Here it is, but you can only use it if it diverges. So this is a little table that tells us what we've done over the last few days. Geometric series, okay? If it was finite, that's the last day and two. Here's our formulas to calculate the sum. Okay? If it's infinite, you got a choice. You got to look at r. And if r is between -1 and 1, then it converges, and you can use this formula. Okay? If r is not between these values, okay, and we haven't done absolute value yet, so you're going to look at this and go, what the heck? Okay? If r is greater than 1, or r is less than -1, then there is no sum. Don't try to use a formula. There isn't one, okay? You got to stick that in your head. Okay, any questions? Blue one or the yellow one? This isn't a formula.
That's just telling you when you use the formula.
You use it if r is less than 1, like a proper fraction. Okay, let's look at a couple examples. I'm only giving you 3 questions here, okay? There's only going to be 2 or 3 on the test like this, but if you want the 2 or 3 marks, you got to know it, okay? Determine the common ratio for each of the following geometric series and state whether a sum to infinity exists. Okay, we have this wording there, but if there wasn't this wording, how would you know what formula to use? You see those 3 dots? That means it doesn't stop. There's no nth term. There's no t to the n. That means it keeps going forever and ever and ever, right? Sum to infinity. So right away you got a clue in, okay, I want my infinity formula if it converges. Calculate the sum where it exists. So the only way you're going to know if you can use a formula or say there is no sum is to find out what r is. What's r? This is multiplied by either a third, right? Okay, yeah, it is a third. Okay, so you got to look, you got to check. So r is 1/3. Is that less than 1 or greater than -1? Yes, it is. So that means it converges, and I can use the formula. S of n is, and this is the nicest one we have, a over 1 minus r. Okay, so S of n is, what's a? 1. R is a third, so what's 1 minus 1/3? 1 over 2/3, which is what? You never want to divide fractions. 1 divided by 2/3. Okay, if you're in my grade 8 math class, which you guys weren't, I've only had one since I've been here, you never want to divide fractions. You want to multiply them. How do I multiply this one? By flipping it. What's 1 times 3/2? Yeah. Okay. 1/2 is 3/2. Okay, which is 1.5. If you don't like those, I know there's lots of people that just love fractions. 1 divided by 2/3 is 3/2. 1.5. And if you still don't like that, you got one of these, you can make that decimal a fraction. Okay? Now, these are both correct. Let me repeat this because people have asked me. Okay? These are both right. But again, if it's multiple choice and this is one of the 4 answers, right, you got to know, obviously, which one to pick. So then if that's what you have, you got to know and put each one of these into your calculator and find the decimal equivalent. That's it. Okay? Okay, next one. I need R. What's R? -5 divided by 1 is -5. Is that less than 1 or greater than -1? Is that in between these values? No. Okay, divergent. Okay, so no sum. That won't be a written question. It'll be multiple choice, and one of the answers will be no sum, it's divergent. Okay, choose that one. Okay. How about this guy? R is, take this, divide it by the previous. Oh, there it is, -1/2. Is that in between? Okay. Yeah, which way do you like it? Do you like it like that, or do you like it like this? This says the same thing. Is R falling in this value? Yes, it is. Okay, so that means I can find a sum to infinity. It's A over 1 minus R. What's 1 minus -1/2? 1 plus 1/2? What's 1 plus 1/2? That's 2/2 plus 1/2 is 3/2. Or yeah, if you like cooking, a cup of flour and 1/2 cup of flour is 1.5 cups of flour, right? 1.5 cups. Okay, so that's 2/3/2. Do you want to divide fractions? No. You want to multiply, but let me write it out. That's the same as 2 times 2/3, which is 4/3. Okay? Last one. The first term of a series is 2. Now they're giving us the sum. Sum to infinity is 4. Determine R. Okay, so I know it must converge because they're giving me a sum there. So we use the formula. Substitute, that's 4. A is 2. I don't know R. How do I solve that thing for R? Well, 1 minus R on the bottom I don't want it on the bottom, I want it on the top. Let's multiply both sides by 1 minus r. What's 1 minus r divided by 1 minus r? Yeah, it's gone. Let's put the 4 in front just to make some people happy. Equals 2. You can distribute that 4, or you can just divide it away. What do you want me to do? So 1 minus r is 1/2. I want to get rid of the 1. So let's minus it from both sides. 1 minus 1 is gone. Minus r is 1/2 minus 1 is minus 1/2. So if negative r is minus 1/2, what is r? Yeah. Multiply both sides by negative 1, or divide both sides by negative 1, or just throw them on the other side of the equation. That makes them both positive. Change the signs. Other way you add, what am I trying to say? Any way you want to do that, fine. Just make sure you get the right answer. Okay, r is 1/2. So all I got is 1, 2, and 10. Then start review in the book. And guys, you want to do all these review questions because a couple of them I like. Okay, we know the difference between the numerical response ones and the regular ones. Okay, these are the funny ones. They got their own numbering system for some strange reason. Okay.